Welcome back, everybody. Now, in a previous video, I introduced the basics of destructuring, and I explained that my main use case for destructuring is when I'm passing arguments into higher order functions like map and reduce. And if you don't have a general understanding of destructuring, check out that video first. If you're familiar with the basics, this video will hopefully show you why destructuring is surprisingly useful in functional JavaScript. This will very quickly become a tool that you don't understand how you ever got by without it. And it has to do with function composition. So let's dive in. First of all, if you're not familiar with function composition and currying, please check out those videos. If you're familiar with these functions or you know what compose does, you're good to go, and you will need to understand currying. So check out those videos if you have not already. Now, what we have here are three functions: add1, add2, add3. And as you can see from the type declarations, add1 takes a number, returns a number, as do the other two. Now, as a functional programmer, you'd hopefully think, wait a minute, I don't need to create an add3, because add3 is actually a composition of just adding 1 and then adding 2. And actually, let me just clear I always forget to do this. Clear that so that nothing's distracting us. And if we run this, we get 4, because 1 plus 3 is 4. But more clearly, 1 plus 1 is 2, and 2 plus 2 is 4, because that's really what's happening in this composition chain. Now, why does that matter for destructuring? Well, I'm going to, before describing that, take a quick aside and explain something to do with how Haskell is built. And in Haskell, all functions are curried by default. What that means is that each function, even if it looks like it takes multiple values, really just takes one value at a time and gives you back a function that takes the next value. And that's because if you're dealing with function composition, like we are up here, we're passing the output of one function as the input of another function. And we can only have one return value. And so if we can only have one return value, that means you can only have one input. You can't have multiple inputs if you're not able to provide multiple inputs. So the composition chain function only has one input. Now, let's say we want to give multiple inputs to this function, add2. And instead of add2, we'll call it add something. And I'll change it up here as well, something. And so what it's going to take then is a number, which will then give you back a function that expects another number, which will then give you a number. So instead of adding 2, we'll add a y value, which we will pass in here. This is a curried function. So the same function that would be written something like this in JavaScript, xy, would be actually under the hood in a purely functional language like Haskell, doing something like this, where it takes an x, returns a function that takes a y, and then gives you the value back, unless, of course, you needed more arguments in that function. Now, this does some weird stuff to our composition chain, right? Because now we are passing in a 1, which goes to add 1, and it gives us back a number, which passes in as the number for add something. So that works just fine. But then it's waiting for another number before it can give us back a number. So what does that mean for add 3 down here, which now is called add something? Well, what we'll get as a result is a function. Assuming that this loads and I haven't mistyped something. Oh, add2 is not defined because it's still called add3. This is what I need to change, not the add2, but the add something, or the add3, but the add something, that guy there. And we get our function back. And that's because add something is still waiting for that second value. And so what we could do is we could say, all right, we're going to add 2, and then our initial value will be 1. And we get 4. So if that's too confusing for you, what that's doing is it's doing something like process equal ag3. Actually, let's not call this ag3 anymore. Let's call this process. Just make it more clear. And so what that would be is something like if we were passing in an initial value to process, and then whatever the return value of that would be, which would be a partially applied add something, then we would be passing in the next value to actually pass through as the input. And so that works just fine. But it would be nice if we could do that from the outset of our program. So we could do something like this. We could do X, we could curry up our process and then just pass in that value there. And so now we'll pass in the 2. It gets passed directly in to add something, and then we can pass in our next value, right? That works just fine as well. But oftentimes this syntax just gets confusing. It would be much better if we could pass these in as a pair. And so what we would like to be able to pass in is a 2 and a 1, or more realistically, a 1 and a 2. Just because I think input first might make a bit more sense. I don't know. It will make sense to me at least. And so the problem here is that then we have to do number, 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 which means that this is going to, and this is how it would look in prior to ECMAScript 2015 or ES6. If you wanted to return, if you were taking in a pair, you could call it whatever you wanted. You just call it XS. And then we would have to do XS, the first value, plus 1. And then XS, the second value, wrap that up in the pair. And we could pass that in down here. And then we could do the same thing on this line. But if we use destructuring, we can do X, Y, and then we can just add X and Y. So let me just get rid of this curriedness down here. And so now we are going to pass in a single piece of data. It's going to get passed into our first function, which is going to transform one part of that piece of data, pass that along to our second function, which needs to be updated with the new function signature. Just jump to the same here. And since those types still line up, everything should work just fine. Run. And we still get 4. Of course, it would make a lot more sense in a real world program to not adjust every single function in your composition chain. But if you're looking at just the point of destructuring here, right, that we were able to pass in multiple pieces of data, and instead of doing this cluttered nonsense, we were able to do some variable assignment in our parameter list and create a much more readable function. And so if I were to do the same thing up here, X, Y, the spaces, by the way, are purely stylistic. I just choose to do that. And that looks, it's so much easier to reason about, right? Now, obviously, it would be a lot more common if you just needed to pass something directly in to this particular example, to just pass in one number and then partially apply add something ahead of time. So the problem now, of course, would be, all right, if we wanted to do add one never should have cared about the partially apply or the second value needed for add something. And so instead, you would want to reduce that back down or make that back to just being number. Take a number, return a number, because that's all add1 really cares about. And then this would just be a curried function again. So in this particular example, you would not want to use that, but it shows you the basics of how currying how destructuring makes using pairs much more practical again in JavaScript, because instead of having to grab them out by index value like we were up here originally, we can just assign them in the parameter list, which makes a lot more sense. And again, if we were to do this, we would do something like x, and then we would go down here, and we would curry our entire process. We would passing an initial value for x, and then our input. Something like, I don't know, 2 and then 1. Remove our extra parenthesis there. And so this would make a lot more sense, because then our types are going to flow in an expected way. But neither here nor there. Let me just make sure this does run, so I'm not showing you broken code. Y is not defined, right? There we go. Awesome. So we're passing in 2 as the initial value to partially apply add something. And then we're passing in 1. So 1 plus 1 is 2. 2 plus 2 is 4. And then we're adding 1 at the end, which gives us 5. Beautiful. Now, a real reason to actually use pairs would look something like this. So now that I've showed you the basics, we're going to get a little fancier with it. We have a function called zip, which again, I'm borrowing from Haskell. And it takes a pair of arrays and returns an array of pairs. Unzip takes an array of pairs and returns a pair of arrays. If we compose these together, they each give us an identity function. Just a fun fact, if you want to learn about identity functions, give them a Google, or if I make a video on them, I will link it in the description below. But the point here is that we're going to make a transformation function called bigger, and it's going to be expecting an array of pairs. And right now, what we have are 2 arrays. We don't have an array of pairs. So if we wanted to use this transformation function, we would need to adjust the shape of the data first, which means that we could take a function like zip, which is going to take a pair of arrays and give us an array of pairs. So what that's going to look like is, if we wanted to make a pair of arrays, it would look something like nums letters. And that's our pair of arrays. That means that we'll be able to pass that into zip, and it will give us a shape of data that bigger can use. So let's write bigger. It's going to take a pair of arrays. I'll just call it XS. And since we are just going to be we're transforming the data, we're not changing the shape of it, let's just map over it. And this is where we would use destructuring. We would do something like X, Y, and then we would return add one, or we're going to need to return a pair to add 1, because we made that function above, so let's use it. And we'll call to uppercase. And let's actually make this a bit more strict. This will have to be a string. This will have to be a number. And likewise, since we're not implicitly transforming any data, a number and a string. And so hopefully you understand this function. That's why I wanted to write it slowly and talk through it as I did it. We are taking an array of pairs, and then we're destructuring it into each value. So we're going to map over it, which means that for each pair, we will grab the first value and add 1, and we'll grab the second value and make it an uppercase. And so let's do that down here. We'll make our composition chain. Just down here. We'll call it transform. And it will simply be a composition of zip, which we need in order to make the data the right shape, right? So we have a pair of arrays down here, and we need it to be an array of pairs so that we can pass it into bigger. Compose it with zip, then we'll make our composition chain out of zip, then bigger, and then we want the data to return to its original shape, so we will unzip it. And now if I do let's results equal transform, I guess I should have just left those there. Nums, letters, console log, results. I'm not sure if I still have a console log above. I do not. Awesome. Now we have incremented nums and uppercase letters. Very cool, right? But guess what? There's actually an even better way to use destructuring. If I go big nums and big letters, believe it or not, that is valid JavaScript syntax now. So I can go big nums, and I get just the incremented numbers. And if I do big letter, I get just the uppercase letters. Now that is so slick. I think that is super, super useful and very, very cool. I think I have thoroughly enjoyed using function composition in alongside my destructuring, and without destructuring, in the ability to destructure or use it as some sort of pattern matching in JavaScript, it really made working with pairs, which are called tuples more broadly, really unpleasant in JavaScript. Now, I wanted to cover the code first in this video, just so that people got some more practical use cases out of it. But as an aside, this is the real reason why this is a factor. So in Haskell, there's a value type called, or a data shape called a list, and it can only have one type inside of it. So you can only, if you have a list, which is the equivalent kind of an array in JavaScript, you can only have one data type in it. You can only have numbers, or you can only have booleans, you can only have strings, something like that. You can, though, have a list of pairs. And pairs, or tuples, can have mixed data types. So those look something, I shouldn't be using arrows. I should be using something like that. They can have mixed data types. But if you have a list of mixed data types, so pairs, then each one has to be the same. So if A was a number and B was a string, every pair in that list would have to be a number and a string. And this works extremely well. It's so nice that they enforce this in a purely functional language, because when you're trying to compose functions together, you need to expect the same behavior from every piece of data that you're mapping over or that you're passing through your composition chain. Otherwise, it's going to break things. And so in JavaScript, we only have arrays. And arrays can be of any length, essentially. They're not limited by things like pairs, where you can only, I think it's 7 is the top that you can have, but generally I use 2 or 3, so I don't really know what the top is off the top of my head. I don't know what the max is off the top of my head for how many values you can have in a tuple. But in my functional JavaScript code a lot lately, I've been using this principle of pairs or tuples in order to pass data through a program when I need to have multiple values passed into a function. And I use those when I want to mix data types. And I do my absolute best, because JavaScript doesn't enforce it, to keep my lists of one data type. And if you enforce this as a programmer, as opposed to being as flexible as the language forces, or the language allows you to be, you will have much more stable code. And I'm doing a more stable JavaScript series, and that's one of the fundamental principles that I'm trying to express, is if you want your code to be stable and predictable, focus on the types. These things matter. These give you stable code where you can write dozens of lines of code without ever having to run it, and be very confident that when you pass data in that first time, you might just get like a syntax error. Because you know, if you're getting a list of pairs that only have a number as the first value and strings as the second, all numbers and all strings have the same behavior. You can count on them running properly through your program, but if you've mixed a bunch of things together, then you have to start doing type checking, or if you're doing a lot of implicit type coercion, those things can get messy. So I highly recommend that if you're going to be diving into composition, use these rules as your guidelines. Lists of all one data type, and then if you're going to pass in data from one function to another, use pairs, which in JavaScript are basically just short arrays. All right, and I think destructuring gives you a nice, clean syntax for doing so. You may disagree. You may find this confusing or not like it for some reason. If you don't like it, let me know in the comments. I'd love to hear from you. If I wasn't clear about something in this video, I know I covered a lot. Let me know, and I'll try to clarify what I meant. And if you'd like to see anything specific, drop a comment down below, and I will be happy to cover that for you. So I'll see you in the next video, guys. Hope you enjoyed this one. And enjoy your weekend if you're watching this live. Bye.